Hello students, hope all of you are doing fine at home along with your families. Okay, after the completion of exercise 1.2 of the NCERT textbook, let us start talking about the next topic. The next topic is irrational numbers. You are already very familiar with irrational numbers. You have studied it in the last class. Do you remember what is an irrational number? Can you give me one example of an irrational number? One example? Anyone? Let's say I draw a square of side 1 unit, be it 1 centimeter, 1 meter, 1 inch, or whatever. 1 unit. And I join the diagonal. Now, what is the length of the diagonal? Length of the diagonal is square root 2 units. You remember how do we get it? From the Pythagoras theorem, what do we do? 1 square plus 1 square is equal to diagonal square. This gives you diagonal square is equal to 2. Diagonal is square root 2. And this square root 2 is an irrational number. We all know that. So simple. Then what are we trying to study about irrational numbers now? We know what is an irrational number. How do we get an irrational number? What are we trying to study now? There should be something different that we are trying to study. What we are trying to study is we are trying to study the definition. A number R S is called irrational if it cannot, see this word cannot, it cannot be written in which form? In the form P by Q, where P and Q are integers and Q is not equal to 0. And you already have the example like square root 2, square root 5 and so on, square root 11. So many numbers like this. Other than that, we have pi, which is an irrational number. Okay. So what is important is that irrational number square root 2, it cannot be written in the form P divided by Q where P and Q are integers. Whatever you do, however you try, you cannot write it in this form. It's simply not possible to write P by Q, square root 2 in the form P by Q. Simple. Went it inside the head? Okay, that was the definition of irrational number. Can you think of any other irrational number? Square root 2, square root 5 and so on. Other than that? Let me make some place over here. Any other irrational number other than what I have written on the screen. If you add any two irrational number, square root 2 plus square root 3, will it be rational? No, it will not be rational. If I add a rational number and an irrational number, will it be rational? No, it will not be rational. We know all those things. If we multiply one rational and one irrational number, all of these will be an irrational number. Yes, so there are many irrational numbers, as you can see now. You can see now? There can be hundreds, thousands, and in fact infinite number of irrational numbers. Okay. Okay, let's move forward. Now we come to theorem 1.3 of the NCERT textbook. The theorem says, let P be a prime number if P divides A square, then P divides E, where A is a positive integer. Do you understand the theorem first? Let P be a prime number. Let's take any prime number. P is equal to 3. And let A is equal to What can we take A? 36. Sorry, A square. Let P be a prime number. P divides A square. A square is 36. So P is dividing A square. Is it? Is 3 dividing 36? A square we have assumed to be 36. P is dividing this 36. Then P divides A. Now if this is true, then P has to divide A. No other condition is possible. If P is dividing 36, P will also divide A, which is equal to 6. Yes, 3 will divide 6. You can see that. But the same thing the theorem is saying. We need to prove this theorem. You want to take another example? Let's take another example. I'll just remove all these things. Take any prime number P. What do you want to take? P. Any number. Will 11 do? Let's take the prime number 11. Let's take A square such that P divides A square. Let A square be equal to 22 square. That will be equal to 484. Okay. So P is dividing A square. Isn't it? P is dividing A square. So if P divides 484, then P also divides 22. That's the simple thing that the theorem is saying. Now we have to see the proof of this simple thing. Isn't it very obvious? If P is dividing A square, then P has to divide A also. Okay, let's go to the formal proof. Now, do you remember the fundamental theorem of arithmetic? We have learned the very first theorem in this chapter, fundamental theorem of arithmetic. Do you remember that? What did it say? Any number A, if it is not a prime number, it can be expressed as a product of primes P1 into P2 into P3, some number of primes into, let's say, up to Pn. Okay? So from the fundamental theorem, let us assume let A be a positive integer, which we are trying to talk about, and this A positive integer A can be broken down into primes like this. Okay, nothing new in this, all the things that we are very familiar about. Okay, now we have a P, we have A, we have one P, we already have that P. We need to find A square first. What will be A square? A square will be square of A, that will be equal to P1 into P2 into P3 into, that will go up to Pn square of that, isn't it? So now P divides A square, that is given in the question theorem. P divides A square. That means P has to divide any of these prime numbers. In fact, P has to be any one of these prime numbers. Whatever numbers we have here, P has to be any one of those. P may be either P1 or P2, P or P3, and P may be equal to P1, or P is equal to P2, or P is equal to P3, and so on like that. P is equal to Pn. Any one and exactly one of these has to be true, isn't it? इनमें से अगर कोई भी true नहीं होगा, then how will P divide A square? P cannot divide A square then. So P has to be equal to any one of P1, P2, P3 or Pn. P divides A square. This means P is equal to either of P1, P2, P3, so on up to Pn. Any one of these. P is equal to any one of these. Let's say P is equal to Pi, where I can be anyone, any number. I has to be one number between 1 to n. So that means P is equal to Pi. Now when P is equal to Pi, then P is P divides, sorry, not P is, P divides A is equal to P1 into P2 into so on up to Pn. That means P divides A. ठीक है ना? If P divides A square, that means P also divides A. We have seen the theorem with the help of examples and we have proved the theorem mathematically also. You have to set this in your mind. You have to set it in your mind. You can take any other example and also see. If you will understand the theorem first, then you will be able to retain it in your memory for a long time. Let's take a big number now. Just for sake of example, I am giving one more example. Let's take A is equal to 3 into 7 into 11 into 19 into 29 into, let's take 53. Let's say P is this big number and our prime P is equal to 19. Okay, so what will be A square? A square will be 3 square into 7 square into 11 square into 19 square into 29 square into 53 square. Such a big number. Now you are seeing it as a product of primes. If the number was multiplied and it was a big number over here, it will be not so visible. That's why the theorem is required. So now P is dividing A square. If P is dividing A square, 19 square is here. That means P also divides A. Isn't it? P also divides A. Okay. Let's see one more theorem now. The theorem is to prove that square root 2 is an irrational number. We all know that square root 2 is an irrational number. There is no doubt in anybody's mind. Everybody is comfortable with that. However, we need to prove the same. So this proof will be a proof by contradiction. Proof by contradiction. What does proof by contradiction means? First, we will assume that this statement is false. First, we will assume that the given statement is false. मान लिया कि वो जो लिखा है वो गलत है. Just let it be. Let us assume that the statement given is false, whatever be the statement. And then we will try to prove that if the statement is false, something mishap happens. The statement cannot be false. Are you getting my point? Let's say, okay, let's see the proof, then you will understand it better. This is a proof by contradiction. Proof by contradiction means let us assume, we are assuming now, let us assume square root 2 is rational. Okay, if square root 2 is rational, then we can write square root 2 to be equal to p divided by q. If square root any rational number can be written in this form, so we have written square root 2 also in this form. Square root 2 is equal to p divided by q. Okay. Now there may or may not be any common factor between p and q. Something may be there or may not be there, we don't know. If there is any common factor, then we convert it to the simplest form. Okay? So let us assume that the simplest form, after cancelling out the common factors, After cancelling everything that was common, let's write square root 2 is equal to a divided by b. And now a and b are co-prime. Isn't it? There is nothing in common between a and b. You cannot cancel out anything from a and b. Okay. Now squaring both sides. To square both sides, you get 2 is equal to a square divided by b square. Isn't it? That means 2b square is equal to a square. Very simple. That means now 2 divides a square. If 2b square is equal to a square, it means 2 has to divide a square. Isn't it? From the previous theorem, there is nothing in common between a and b. There is nothing in common between a and b. In the prime factorization of a and b, there is nothing common. And there is a 2 on the left hand side. So right hand side should also have 1 2 somewhere. So 2 has to divide a square. When 2 divides a square, then that means 2 also divides a. Isn't it? 2 also divides a. So we can write a is equal to 2 times c. A is equal to 2 times c. Substitute for a in this equation. What do we get? In equation 1. We get 2b square is equal to 2c square, that is equal to 4c square. That means b square is equal to 2c square. Okay. Again from theorem number 3 we have 2 divides b square. This implies 2 divides b. Isn't it? Now see, 2 divides a and 2 divides b. 2 is dividing both these numbers. Is it possible? Is it possible? No, it is not possible because we had assumed that a and b are co-prime. We had already assumed that a and b are co-prime. So this cannot be true. Because a and b are co-prime. Hence we arrive at a contradiction. Therefore, square root is irrational. When we assumed that square root 2 is rational, we arrived at a contradiction. We arrived at something that cannot be true, that cannot happen. and that cannot happened because we had assumed that square root 2 is irrational. That means our assumption is wrong. Our assumption is wrong. And what was the assumption? Assumption was that square root 2 is rational. Okay. In mathematics, we will prove quite a number of theorems like this. Very often you'll see proofs like this. You assume something and then you prove that our assumption is wrong. Okay. That was the proof that square root 2 is an irrational number. Now you need to learn this proof very nicely. After watching this video, try to do this in the notebook. Watch the video or see the textbook and write it down in the note as you can. Because this is very important from the exam perspective. It's highly possible that this question comes in the exam. So you need to know it. Anyhow, you need to know it. So learn this. If you don't understand, we will discuss another example, similar example in the coming video, next video. Even after, if you don't understand, you can ask me. I'll guide you. Okay? Till then, stay safe and stay studying.